Namaste. Welcome to tutorial series on SuperPro Designer for beginners, step-by-step guide to process simulation. In this video, let us understand the difference between ferment and react operations available in a batch procedures. For example, we go to this batch vessel and select a reactor. You can notice there is like a lot of operations could be added. One such important operations which is used in chemical and biochemical industries is like this ferment operation and react operation. So why we need to have two operations? Why can't we use react in all the time, or why can't we use ferment all the time? So there are basically the technical difference between a reaction and a fermentation, and we need to set up in different ways because the reaction requires different equations. Like for example, the way the reaction orders, like reaction is mentioned or specified, it is entirely different from fermentation model equations. So let us go with one by one. Let us add this ferment kinetic and react kinetic, and let us understand what is the difference between these two. So I'll just go first with the react operation. If you could notice here, we have used many times, frequently used this operation. Purely chemical reaction, when it is a purely chemical reaction, we go with this react operation. All the other options are available, like fermentation option also. And in this case also, you can set up the fed batch operation. And when you go to this react operation is very important, as I have chosen the kinetic reactor, so we can feed the kinetic information of the reaction. So this is the dialog box, or like edit stoichiometry, which is used to set up the equation. You can set it in mass basis or molar basis. And also when you go to this R symbol, where we need to feed the kinetic information, when you click this, you can notice that the rate reference component reaction order could be specified, and reaction inhibition terms are there. If it is any inhibition is there, for example, any reactant is inhibiting the reaction, you can add this inhibiting terms, and you can set up this rate constant here. So the basic you can, if you have Arrhenius equation constant, pre-exponential factor, and Arrhenius that is activation energy, you can add it here. So these are the different components. You can also select this set criteria. There are like advanced options are available here. This is the react kinetic operation, that is react kinetic operation. So let us go to this ferment operation, ferment kinetic operation. So in this dialog box, you can notice the major difference between the react and ferment operation is this is the box where we can see the broth aeration, because during the fermentation, if it is aerobic fermentation, definitely you need to charge the air. So even some case of anaerobic fermentation also, sometimes initially it required air, oxygen for cell growth, and later we stop the aeration and further we'll make it completely or 100% anaerobic process. So this dialog box you can notice where we have an option to set up the flow rate of air, that is VVM, flow rate of air. And also when you can set up fed batch. If you go to reactions, the very important thing, again the same, a similar one compared to the react kinetic operation. But when you see this particular like kinetic constant, where we set up, you can notice all these informations are available. So for example, you can notice monadic equation is there, Haldane equation is there. If any inhibition is there, you can add this inhibition constants also. If it is just first order, we assume with the first order. So here we have, for example, here the mu max, alpha, beta, Ludeking Piret equation, which is used to represent the mixed growth inhibition, growth dependent, non-growth associated components. All these advanced options are available in batch kinetic fermentation. So these were not available when we saw the react operation. So that is the reason whenever the fermentation aeration is there, when the purely fermentation is going on, better to choose this like kinetic fermentation option. In some cases we saw you during fermentation also, we represent just a reaction, conversion of one compound other component. That time we can go with batch kinetic react operation instead of fermentation operation. So click OK. I hope you understood what is the difference between this kinetic and ferment operation. And let us add two more operations. That is, one is batch stoichiometric, ferment stoichiometric, react stoichiometric. Click OK. Let us go with react stoichiometric. Here the purely chemical reaction. Rest all are similar to the kinetic one what we have chosen. But when you go to the reaction, earlier we used to see the R symbol where we need to add the kinetic data. But in the stoichiometric, where there is no kinetic information, here we need to set up the conversion. So how much percentage conversion, whether if you already know what is the remitting reactant, you can set it up, or else software will also automatically calculate which is the remitting reactant in the process. So this is the react operation that is based on stoichiometry. And ferment operation, it is again similar to the previous ferment kinetic operation, but in the only difference in the reaction is again there is no R symbol here, because when you don't know the kinetic information, then you try to use this stoichiometric operation. So again you need to add all the information. So basically the main difference between these two is this aeration one. That is very important between these two operations. The fermentation and chemical reaction is basically this difference. And also if you have like you can add other operations, go to add or remove operation. In fermentation there is something called as perfusion process. I hope all of you are aware of this perfusion process. Basically this perfusion process is like we use for high cell density process, means continuously the that is the difference between continuous and perfusion. In continuously the broth is removed, you are adding the media, you are removing. But in case of perfusion, the contents of the reactor or bioreactor is removed, but the media, the reaction components or products are removed, but the cells are again sent back to the reactor or bioreactor to maintain the high cell density. That is the basically a perfusion reaction. So the broth is continuously drawn or filtered, and that whatever the biomass we get, that again sent back to the reactor to maintain the high cell density. Obviously the high cell density, high product will be produced. And here you can notice there is an option. Earlier we could able to see fed batch, but here there is something called perfusion, and you have to mention here if you click on this perfusion mode, obviously two things will highlighted. Obviously perfusion need to be have two again extra inputs. One input continuously you add the media, and another output continuously you draw the media, and we need to connect it to a filter, and that will be recover the cells, and we have sent back to the reactor. So this is basically we can have an option to set up this one. And even you can go to this reaction operation. Again basically it is kind of a stoichiometric, you cannot set up the kinetic information in perfusion operation. It is basically kinetic information could be set up. This is about perfusion operation. And next one, in case of react operation, there is one more called react equilibrium. So let us open and check what is this react equilibrium. Here again the rest all parameters are like a default, and you can notice there is no fed batch here as the reaction equilibrium reaction. And here also you can notice the R symbol is available. Definitely this is slightly different from the previous react kinetic operation. You can notice you can set up the equilibrium concentration, equilibrium coefficient, that is K equilibrium could be set up, and all other coefficients could be added here. And also you can add the equation here. And if you know the heat of reaction, if you uncheck this, all the advanced options are available. And also sometimes you can calculate the reference component. If you don't know the what is the reaction component, here it is not added any other component. If you select the reference component, software will also provide you some opportunities to calculate the enthalpy or reaction heat. So these are the different reaction and ferment operations available. So depending upon the requirement, we can choose them. I hope you understand the difference between these two operations, that is ferment and react operation. Thank you for watching. Please do not forget to subscribe.